Hi, what I have here today on the bench is a BSide ACM03 Plus 4000 counts clamp meter. I got this meter a few months back when I was doing my spot welder project, as I needed a way to measure the high current through the welding tip. As it turned out though, the current was significantly higher than what this meter is capable of measuring, and the estimated current on the secondary is more than 1000 amps by the current readings from the primary side. Anyway, a couple of people had asked me privately whether this meter is any good, so I decided to have a quick look so that you can decide for yourself. First thing first, let's put this meter into perspective, as this is a very cheap clamp meter. I bought it off eBay for about $25, and at this price point, you probably couldn't find a better deal than this, as it offers both AC and DC current measurements and also has many more features. My understanding is that this meter was distributed by Shenzhen BSide Trade Corps, and like many cheap Chinese goods, it is probably just a generic product stamped with multiple brands for different markets. So I wouldn't be surprised to find out that there are some other meters out there that are functionally identical to this one, but under a different name. So this meter came in a rather generic carton box, like this one, and also it was packed in this nice little pouch, which I actually kind of like, because you can kind of carry it around inside like this. So the leads, oh by the way, also it came with this instruction manual, which is better than none, but usually you don't really need this manual anyway, so I'm not gonna say too much about that. So the leads came with this multimeter. It's reasonable quality. I mean, it certainly looks cheap, but it's slightly better than a lot of the ones that I have seen so far. But of course, for a clamp meter, most of the time you wouldn't be using this leads anyway, so you would just use the meter itself. Now, speaking of the meter, I'm actually quite pleasantly surprised of the build quality. At first glance, it's just plastics, but when you feel it, it does feel very, very sturdy. Not like some meters where you can, kind of twist it, you will hear the squeakiness from the meter, but this one actually, it's quite sturdy, and it feels really heavy in your hand as well. And the clamp is quite tightly springed loaded, so that depends on who you are, what the situation is. You may like it, may not like it. So now let's take a look at the switch here. The switch is a thumb. Basically, the idea here is you can use a thumb to switch it, and it's reasonably the quality feels okay. But one drawback is that this dot indicates where the current location is at, and because it's a blue switch dial, and there's no color differentiation, so sometimes it's a little hard to see where you set this range at, and especially when you are setting it at the NCV, the non-contact voltage reading side, and you notice that the display is actually off. So sometimes you could mistaken that the meter is actually off, but it's really on. So this is just some minor complaint that I have from looking at the meter dial. And so let's move on to some of the more substantial things. And remember, because this meter is so cheap, and also it is mainly a clamp meter, so it's mainly for current measurement. So I'm not going to be too picky about its the functionality here for voltage and resistance, capacitance, diode, those kind of measurements. But nevertheless, we will kind of go through a few of those before jumping into its main current measurements. So before I go ahead and test this, let me just show you the specifications of this model. So what we're seeing here is the ACM03, and it's a 4000 count meter. And actually there's another model, ACM02, which is a 6000 count meter, and it also offers a microamp measurement range, but that microamp range is actually just between the common and the input. I'm not particularly interested in that meter. You don't switch this input, doesn't have a dedicated current input for current measurement, so I just think it's inherently unsafe. But that said, if you are interested in the higher counts, and also if you need that functionality, you may also check that one out as well. But this is one we have, and it's quite impressive actually from the specifications here. As you can see, that not only is able to measure the DC voltage, AC voltage, and also they're relatively accurate at 0.8% for DC and 1.2% for AC. And also they can measure current, both AC and DC, up to 400 amps with a 3% accuracy. And resistance, it can measure all the way up to 40 mega ohms. And also you can measure capacitors from 40 nanofarad range to 100 microfarad range. And from the frequency measurement, again, we can see from 50 Hz all the way up to 100 kilohertz. And non-contact voltage ranges from 90 volts to 1000 volts. So now let's take a look at the display here. And the display is a little small but very crisp LCD display, and in fact the update rate is about twice a second, which is a little slower than some of the meters, but nevertheless fast enough for most of the use. And here basically each of the range, the auto ranging range here can be multiplexed. Depends on how many functions it has. You can press the select button to select between AC, DC, for example here, and some of these are actually multiplex for more functions. For example, here is both your the resistance measurement, your diode, your continuity, and your capacitance measurement. So it does have a dedicated Hertz, and also this, I believe, is a Hertz, and also you can tell you the duty cycle of the signal here. So that could come in handy, and then your current measurement up there. So now let's take a look at the performance of this meter. For reference, I'm using this Keithley 196, which is a 6.5 digit meter, so it's plenty more accurate than the meter we're trying to test here. So, and also I'm using that the DC current, the DC voltage standard I have up here. That, as you can see, that EDC 621. That's the voltage standard. Right now I set it to 5 volts, so which I'm going to put it up here, and let's see if it's 5 volts. And also I have two sets of leads here. So the first set I'm going to hook up to the my reference meter here, and the second set I'm going to connect to the BSide, to this clamp meter here. So let me now just turn it to voltage DC mode, and let's see here. And as you can see, we are not too far off. We're just about 1 or 2 counts off, which is more than adequate for our, let's just see if we can put it at a place where both meters can be seen, can be read. I think here is probably the best. Okay, so now it's 5 volts. So let me come up here and adjust the voltage a little bit. So now let's go down to 4 volts, 3 volts, 2 volts, and 1 volt. So the BSide is a little bit off, but nevertheless it's it's well within the plus minus 0.8% error range. So now let's take a look at while we're on this voltage, let's take a look at AC voltage measurement. For that, I'm going to do something slightly different. As you can see here, I have my function generator which is this WaveTech 100 megahertz function generator, and also through that I connected to 2 sets of BNC to banana leads. So I'm going to use that to hook up the my measurement here. So just give me a minute while I set it up, and after that we can look at our meters here. Okay, so now I have set it up, and now I'm outputting a 60 Hertz sinusoidal wave, and to mimic our AC power line. And the voltage I'm going to set to 1 volt RMS. So now let's change this to AC. Oh, so that's peak to peak, so it's 2 volts. So give or take. So let's increase the resolution here. So now we roughly see 2 volts on the left, and let's change this to AC mode, and it reads roughly 2 volts. So not a problem. So for easy references, let me change it back to 1 volt. So let me change my, just bear with me 1 second. Let's change it to 500 millivolts peak to, this is a RMS. So that's 1 volt down here. Okay. So now, as you can see, both meters agree with each other. So what I'm interested in is what is the frequency range of this BSide meter. So for that, I'm going to increase the frequency gradually from 50 Hertz till we get to the 3 dB bandwidth, and we will decide. We can see then what is the bandwidth available for AC measurements. Okay, so now I'm going to increase. Now it's 100 Hertz, not a problem. And let's see, 200 Hertz, not a problem. Let me do 500 Hertz here. So as you can see that our meter here, the BSide meter, it started to drop after we increased over a couple hundred Hertz. And so clearly this one has a very narrow bandwidth for the AC measurement, whereas for the Keithley 196, I think the bandwidth is at least several kilohertz, if not much higher. So let's keep going. Now it's 1 kilohertz. Okay, 1 kilohertz. So let's keep going. Two kilohertz. 3 kilohertz. 4 kilohertz. 5 kilohertz. I'm guessing it would be roughly now it's a 6 kilohertz. So as you can see, probably the bandwidth is about 7 kilohertz. It's actually just shy of 7 kilohertz. So it's probably 6.7. So somewhere in that neighborhood. And whereas for Keithley, you can see it's still reading at 1 volts. So clearly, this one, has a little bit of a limited bandwidth. But what I'm more interested in is this meter is not marked as a true RMS. I'm trying to see what kind of response it gets when we're inputting a non-sinusoidal wave. So let me change it back to 60 Hertz. Okay, so now we change it back to 60 Hertz. And now I'm going to change the waveform type from sine to a square wave. Okay, so now also I'm going to change the amplitude to 1 volt. Okay, So clearly, as you can see, this is not a true RMS meter, because on the left side we can see that we're reading out 1 volt, whereas on this BSide meter we're reading 1.111. So even though this is a 50% duty cycle square wave, and so we need to keep that in mind when doing our measurement. Now, after the voltage measurement, let's take a look at some of these, the capacitance, resistance, and diode, and our continuity measurement. Let's first go to, I think the default is resistance mode, and let's measure a 1.25K 1% resistor. And let's just focus here. Okay, so 1.25. And let's take a look at how accurate this can measure it. The first thing to notice is it's actually really slow. And each range is taking about half a second. So clearly, the result is actually not bad. The result is 1.25 spot on, but nevertheless, the speed at which it measures is really slow. But that said, if you're just using it occasionally, that shouldn't be too big of an issue. So just for comparison, actually, when I reviewed my analogic true RMS multimeter, I also mentioned that this resistance measurement it's quite slow as well. So let's see how slow that compared to the analogic one. So by comparison, I mean the analogic actually is much faster than this BSide one. So clearly this is not a very fast auto-ranging meter. So now let's see what we get when we are measuring the, let's see, now it's a diode. For diode, we can, let's just get a diode here. It's so we can measure the voltage drop. Let's see if we can measure this LED using diode mode. This is a blue LED, so nope. We can't measure blue LED. So let's take a look at what is the voltage output for this. Because I'm expecting that, because it has 3 AAA batteries, I thought it would be able to output enough voltage for measuring a even a white diode. But let's see here. Nope, it's only outputting 1.5 volts. So clearly we won't be able to measure the voltage drop across an LED. So now let's move on to measuring capacitors. This thing is also rated for to be able to measure capacitance. So let's see how well it does it. So let's take a look at the continuity mode. It's fast enough, yet it's not latched, so clearly the quality of the probe would affect the continuity test. But nevertheless, it's okay. So now let's take a look at the capacitance measurement. Now for capacitance, this meter is rated only to be able to measure up to 100 microfarad, so it's really limiting. But for that, let's just check this 1 microfarad capacitor. And it does measure 0.98. I'm not sure in terms of accuracy. Let's check it with this analogic one. Not to say that this one is more accurate or less accurate, but we just have a comparison here. So let's take a look here. And it's a 989. So it's a relatively, it's pretty much the same. Yet, the speed, again, this BSide one is on the slow side. So it does take a second also to read your capacitance. But remember, the main reason we have this clamp meter is not to measure you know, the other stuff. It's mainly to measure the current. So I'm okay, you know, at the speed it's going, as long as it can do the other stuff reasonably well. Before I forget, let's actually jump to this frequency measurement. The frequency, it is rated to be able to measure 100 kilohertz. So let's take a look at how it's doing that. And for that, again, I'm going to hook it up to my signal analyzer. I mean, sorry, the signal generator. Right now, it's generating a 1 kilohertz sine wave. So what I'm going to do is I'm going to increase it 1 kilohertz by 1 kilohertz. And we'll see at what point this frequency counter stops working. So now it's let's just go directly to 100 kilohertz because that's what is rated maximum. Okay, so now it's 100 kilohertz, and it's still holding up. So let's go up to 200. Let's go by 10 now. 110, 20, 30, 40, 50. Wow, so it's still going pretty well. 60, 70, 80, 90, 200. So right now we're doubling the its rated range, and it's still holding up pretty well. Let's go to 300, 400, 500. Wow, I'm actually pretty impressed by this. 6, 7, 8, 9. So it's still going. 1 megahertz, still no problem. 1.1, 1.2, 1.3, 1.4. So it's somewhere after 1.4, it's no longer able to. So 1.3, that's pretty much the maximum frequency you can measure. So now, as you can see, my meter, sorry, my signal generator up here, it's set to 1.3 megahertz. So that's actually pretty impressive. And a lot of meters nowadays include this non-contact voltage alert. The use for that is if you are near a electric field, high voltage field, without having to poke any of the contact, it should tell you whether or not there's a dangerous voltage present. Unfortunately, some of the implementations are, you know, it's not really reliable. So let's take a look at this one. So let me unplug the probes and change it to NCV. Now, the one thing I didn't like this NCV is, you know, as soon as you turn to an NCV, the display goes blank. So it's kind of like inconvenient. You don't know whether it's on or off. But let's get close to this power cord. So as you can see that it's not very, it needs some kind of, it's really not very sensitive here. So this is actually the main, it does give a, once it detects it, it does give a nice beep, and also the light in front flashes, which is also nice. Oh, speaking of light, we can also see the backlight here. Let's take a look at the backlight here. Okay, I need to hold it. So the backlight is reasonably nice, and actually the contrast is pretty high. But the non-contact voltage, so to me, it's not very useful if you cannot detect this reasonably. Another thing I noticed is that the bench outlet is actually, the whole strip is made of metal, so it actually cannot test. It will not be sensitive enough to tell whether or not it has power. And because this is a clamp meter, so I know what you're thinking. We have to take a look at its current measurement capability. So now I have a power supply outputting a 1 amp current through my power supply. And now let's take a look at whether or not we can measure this current using the clamp meter. So I set it to 40 amp. Right now it's in DC amp mode, so that's correct. That's what we want to measure. And for these kind of clamp meters, we always have to zero out the current. So now let's zero it out, and let's take a look. And we're measuring 0.99. It's negative because it's coming in from the other way around. So if I do here, it's 0.99 again. So that's actually relatively accurate. And by the way, so one trick to do is that when you are measuring, let's say, smaller current, let's say this current is far less than what this meter can register. A trick is that you can actually wind it multiple rounds, like this, like so. 1, 2, 3. 2, 3, 4, 5. Let's do 5 rounds, right? So now I should have a current 5 times what the actual current flowing through, because now we have the net 5. The current goes in 5 times. So that's just a trick that you can use when you are measuring current using a clamp meter. But nevertheless, you know, it is relatively accurate, and it certainly fits in its suggested specifications. So now it's time for us to open it up and take a look. So the first thing I want to show you actually is this battery compartment, and actually I like it quite a lot because it uses the standard AA. Is it AAA or AA? Let's take a look. It uses the standard AAA rather battery. Okay, for some reason I can't take it out. Okay, AAA battery, and so it's available, you know, most of the places, and it's actually cheaper and lasts longer than the 9V battery. And nowadays a lot of the meters uses the internal voltage is you know, only 4 volts or 3 volts. So really you don't need the 9V battery in there. But for convenience, a lot of the meters still uses 9V battery only. So now let's take a look at the inside. We only have 3 screws to work with, and these are just self-tapped screws. And after I remove 2, there's another one at the bottom. So after I remove it, so look at this, it's actually pretty dirty. I'm not sure what that is, but it might just be the plastics when we're doing the screws here. Okay, so once we get the screw open, so here is the inside of the unit, and from a first glance it uses this unknown chip, which I will have to take a look at what chip that is, because there are not that many multimeter chips. We can probably easily figure out, and at the very least we can kind of figure out which group of chips it's using. And here it seems we have a let me take a look. It is a, I don't know off my head from the components, but it could be an op amp, I'm thinking, and there are quite a few trim pots. So clearly the trim pots are used to calibrate the meter here. Now there is a 8-pin device here. I'm not sure what that is. It could be an EEPROM, but given the proximity to the current clamp, this might be a Hall effect sensor amplifier or some type of device to that nature. Because this, you know, because this can detect both AC and DC current, so we know it's a Hall effect sensor inside. So, and I'm not going to take this out because I think the other side is just for the keypad and some of the push buttons, and there really isn't anything there, and except for this LCD, but those are pretty standard stuff. So this spring is, the tension is, wow, yeah, it's quite high, the tension here. So let's take a look from the input side, and you know, The soldering job here is, I mean, this kind of arrangement is probably not meant for the long reliability type of design, because after you push in the pin, take out the banana plug numerous times, you could crack the joint underneath here. But again, for a clamp meter, probably doesn't matter that much. And you notice that the input protection is really pretty much non-existent. The only thing we have here is this PTC, and even the PTC is a tiny one. So again, because most of the time we're not using this to measure voltages, and it's only rated for, well, actually it's rated for Cat 3. So I think the Cat rating might be, probably not quite there. But other than that, I mean, there's some, this, I don't know why this wire has to go all the way from here to here, but clearly that's what they had to do. And in fact, there's not even a soldering pad for that. It's just a wire directly off this transistor to the other end. So clearly there's some minor design issues. I mean, they probably don't have enough space to route another wire given the layout of everything else. So that is probably legit, but at least put a footprint for the wire here. But other than that, I mean, there really isn't too much you can complain about, because this is just a $25 meter, and also it packs quite a bit of functionality in there. So in fact, I'm gonna do some research on this chip to see if there's anything we can do, like what we did with the analogic meter, that we hacked the IR off that meter. And I think if I can find information of this chip, we can do something similar. So anyway, so now I wanted to say that this meter overall is it certainly suits my needs, especially just for the current measurement alone. I think it is well worth the $25. Now, would I use this for my standard meter everyday use? Probably no, because the measurement, especially the capacitance, resistance, continuity, I mean, those are just way too slow for my daily use. But that said, if you just carry 1 meter with you, especially given how rugged this meter is, and occasional use, if you can stand the slowness, that certainly is nothing. It's really not a problem. So I think, given the price point, even though there are some drawbacks, I think it's still a pretty decent clamp meter. Especially it's very robust, and it also has some neat functionality built in. Anyway, I hope you enjoyed the video. If you did enjoy the video, please give it a big thumbs up, and do remember to subscribe. I will catch up with you next time.